All right, welcome to the stream, folks. Couple new things. Getting more active on Instagram, posting flashcards and some other stuff. So posting kind of pictures of my setup, things like that. Also, we got a new topology, so really excited. We're off just to layer 2. Now we got layer 3. This is basic addressing kind of configuration. So I've got I did this new drawing. Of course, like a lot of people, I'm basing off the INE topology setup to recognize the address scheme, but I redid the drawing just to do one of my own and to make it a little easier to read for me. Some different color coding and stuff like that. So fired up Visio. Figured the lab topology and VIRL. I had to add a little bit of memory. Normally I use 8 gig of RAM. But I was tweaking the configuration a little bit and got that prompt about not having enough RAM. So I boosted it up to 9 gig. So far, it seems to be running okay. Of course, it's slower. Got all 10 routers running right now. Seems to be working fine. So we'll see. I don't have any dynamic routing protocols running yet. Just the basic IP addressing. And I'm also trying to switch to OneNote because with these notes, have to do a lot more prep. I'm gonna have to do a lot more study to prepare for some of these labs. You know, I've done a lot of the videos. Excuse me. I've done a lot of reading of books, and I'm gonna get to the point where some of these labs I'm gonna have to break out of lab mode, go do more reading and study. So there might be more time between labs. I'm still going to try to do it every day, at least one. Today's lab is basic routing and some Proxy ARP. Good stuff on that. I had to study up on that. There's a great document here. I'll post it too in the link description on YouTube. But essentially, you know, where would you see Proxy ARP being used? And just to kind of review, that's the pace in my OneNote document. I'm going to actually pull up the Cisco doc because it's really good. Actually, now, Cisco they've got good documentation most of the time. But you know, it gives a little use case here, and essentially where you've got a host that I like this example. I don't know when this would come to play in a modern network in the real world, unless A, there's a misconfiguration, B, some sort of experimental use case, because from what I've been reading, a lot of proxy ARP can actually represent a security. So I know in a lot of cases we've actually disabled in my job. We disabled Proxy ARP or no IP redirects. Also, I'm not going to get into that here. Just focus on Proxy ARP. But here, you've got a case where you've got a device, as it says here, host it has a /16 subnet mask. In other words, this host believes it is directly connected to all of 172.172.16.0.0. These other devices are using /24, so the router is basically going to proxy ARP that to get to the B side. There's subnet B, this other broadcast domain. So we're going to play with proxy ARP in this lab. I've done my basic research. I looked in the command reference. The command reference is basically, you know, you can disable it globally or by interface. Some good stuff and advantages, disadvantage. And again, use case, main advantage, proxy ARP can be added to a single router and network, does not disturb the routing tables of other routers on the network. Proxy ARP must be used on the network where IP hosts are not configured with a default gateway. There might be some old applications out there or some old, you know, maybe special types of manufacturer networks. You know, I've seen, I guess, some old sort of in industrial environments where you have equipment that you cannot configure a default gateway. I have seen some cases like that. This is going back a few years though. Devices that don't have any routing intelligence. In this case, you might have to have Proxy ARP. So I guess I have seen in the real world a case or two. I don't remember if it was cameras or, telemetry devices. But I do remember some cases of this. It might have even been wastewater or power plant. Anyway, disadvantages. Obviously, the ARP traffic is increased. Your hosts need larger ARP tables. Security can be undermined. Machine can claim to be another in order to intercept packets. Yeah, spoofing. Yeah, and it doesn't translate well to all network topologies or technologies, obviously. All right, so let's get in the lab here. So this is our new topology. I'm going to put it down here. We're basically going to be working in this segment, which is 155.1.146.024. Routers 1, 4, and 6. I'm going to be verbalizing a lot of this because a lot of this is new to me. This whole scheme here. So used to just doing layer 2. So first thing in our lab is IPv4 static route for on router 1 or router 4's loopback 0 prefix. So yeah, we got these loopbacks, which obviously without any dynamic routing protocol, this router is not going to have any idea how to reach it. /32. Let's just confirm that here, because I've just loaded these configurations into these routers, so I'm not real familiar with that. But if I do show IP brief, I've got my loopback. Okay, that's what it should be. Also got IPv6 set up too. Yeah, I'm looking forward to doing a little IPv6. I don't know why, but I've got my 146.0/1.146 is on that segment. 155.1.146.1. So if I want to reach router 4's loopback, I have to use the next top with the value of R4. So yeah, obviously we need to be able to go. This is going to be 146.4, I believe. Let's switch over there. Lost my connection. So on the 146, I'm 155.1.146.4. I need to reach this loopback. So I'm going to do just the basic static route. IP route 150.1.4.4. Is that right? Are we in the 150s? Yes. 155 is its tunnel network. Just reviewing real quick, Jet 00. I don't even know where that's going. Is that representing a host? Oh, we'll find out. 01 is the interface I've got split up here. Got sub interfaces .13. Yep, going that way. I've got a 100. This is going into this DMVPN. 169.254.100.1. Is that a special network? 69 network. Sorry. So obviously it's not RFC 1918. Let's see. The 169. I'll come back to that. I'm going to keep going. 155, 1.146.1. Okay, that's on this segment. So I need a static route. And 205 because that's /32. And the next hop route is going to be here 15.1, 6. Okay. So show run. Do I have anything else in it? Should not. Got no routing protocols running. Yeah, we're just doing static routing. Can I reach my next hop? Yes. Can I reach? Well, I won't be able to reach the loopback yet because yeah, I can. My source of the ping is going to be on this 146, so we're good. All right, next R2, or sorry, number 2, R1. IPv4 static route for R6 loopback using only R1's Ethernet outgoing interface. All right, basically same thing. Different wording. IP route, and that's going to be 150.1.6.6, and via 155.1.6.6. It's going to take me. Yeah, it works. But I'm going to be using this topology for a long time. So at a certain point, I should know this network. Which I don't know if that's good or bad for the lab, but we'll see. Okay, number 3, disable proxy ARP on connections to VLAN 146. So it's not going to be global, but on R6, we're just going to want to disable proxy connections on that interface, which is 1/146. Yeah. No IP CR. I think it's a hyphen. Yeah. Validation. So besides a show run, is there another way to see that? Show has 0.6. Yeah, I'm not sure that we can actually, except for doing a show run. Okay, show IP ARP interface GI 0. Okay, nice. So got it for now. This is showing ARP entries, right? So I could do any type of interface. I could do a show IP ARP for a specific entry. I've done that before. Multi-link. More interface types, and then finally incompletes. That's cool. None right now. Max number of uninstall, max number of retry attempts 20. Interesting. Okay, just kind of playing right now, but that's so it is disabled. The only way I guess we can tell, doing a show run, no IP proxy ARP. Interesting, we have encapsulation.1q enabled. Okay. Number 4, ensure that R1 can ping the loopback interfaces of R4 and R6. All right, I did that before, but that was before I disabled proxy ARP. Shouldn't matter. Ooh. Well, that's because I don't know what 4.4 is. Second. Okay. Loopback ping 150.1.6.6. Yeah. Nope, that still don't know. It's address scheme. Ping 150.1.4.4. Okay. So from what I'm understanding here, this next number 5, modify R1's ARP table so that it still has IPv4 reachability to the loopback 0 interface of R6. But I already have loopback reachability. Let's see if I did this right. I wonder if I did this wrong. So on router 6, disable proxy ARP. Oh, I did number 2 wrong. So using only R1's Ethernet outgoing interface. Very subtle difference here. So what we're doing is we're doing an interface next hop. Number 2. Yeah, so we need to delete that. See, on an exam, you have to read between the, well, not read between the lines, but pay close attention to what is. Oh. What you need to do is IP route 150.1.6.6 based on an interface. That's what it's saying. R1's Ethernet outgoing interface, which would be GI016. Now, am I able to reach ping 150.1.6.6? Because, so the difference here is who am I going to ask to get to that route, right? So number 1, I'm saying my ARP frame is going to have the destination MAC address is 0000, but it's going to ask the next hop router, and it's going to get there, and that will be the entry in the ARP table, right? IP ARP. Yeah, that's incomplete right now because, all right, so thinking about this, if I try to reach 150.1. Is it already timed out of the ARP? Doesn't stay in the ARP table at all. No, what happens to it is have a route for that to the next hop router. Okay, however, for 6.6 is going to be incomplete. Because it uses Proxy ARP. I've come across this before when I've used, I don't remember why, but I had to use an interface as the next hop destination for a route, and it does significantly impact your ARP traffic coming from this. So we have to create, what is the saying to do to fix it? Modify the ARP so it has reachability to the loopback 0 interface of R6. So we can create a static ARP entry for that. So we know in order to do that, we have to know what would be the destination MAC address. And that would be the next hop router interface. So I have to know the MAC address for this interface here, right? And that interface IP 146.6 is here. So hardware address for that, what we want to use. IP ARP. The entry is going to be 150.1.6.6. That's ARPA, right? There it is. So it's no longer incomplete. We ping it. Yes. Okay, so interesting that we could not do IP ARP, resolve that. We had to use ARP, and I did not research the ARP. Let's go ahead and look at that. I think that's under configuring IP addressing. So finding a static ARP cache. Right. Globally associates an IP address with a media address in the ARP cache. ARP IP address hardware type alias specifies the hardware response as if it were the owner. Okay, as if I'm the owner, it's ARP address, and then sets the ARP timeout. ARP encapsulations, yeah, I'm not familiar. I read about this. I just happen to know that it's ARPA. These others are used another layer 2 addressing schemes, right? And then mobile ARP, right? Okay, well, we got through the exercise. I think that's going to wrap it up for this lab. If you like this video or the stream, hit like or subscribe. I'd appreciate it. And check me out on Instagram at the LAN Tam.